In this demo, I'm gonna show some automation DevOps tools on Microsoft Azure. Mainly our focus will be on building a full automated CI/CD pipeline. Our application we are gonna use is building a machine learning app using the Python Flask tool, which will be deployed on Microsoft Azure App Service, which is a platform as a service. That's our repository we are going to work in. Let's clone that. These are our repository that we are gonna work on. First of all, we have our make file. I think it's a better way to move on the steps in the Get repo. So you can check these time and schedule plans it takes to make that project. Mainly this is the way of DevOps automation go through. It's not the only way. It's not a full representation of how DevOps automation works. It's not a simplified representation. Okay, first of all, the developer is going to commit the application code on the repository. The repository could be on GitHub, GitLab, Bitbucket, whatever the software as a service repo that you are using. Even you could use cloud native repositories such as on AWS, the code commit service. On Microsoft Azure, we have the repos service. But what we will use here is GitHub will be our repository version control system. Once a commit or a change occur in this repo, for instance, if there is a get push action has been made on one of our branches, either the master branch or other branch, also we could specify which branch to listen on the triggers, as we will see later on. So every trigger occurs as a continuous integration build will occur and a continuous integration testing, because a continuous integration had two types, either building or testing. Building, it could be building our artifacts, maybe our exe file, or if it is a ASP.NET app also, or our Python file. Also it could be our zip file, which has all of the code of our project. These are the artifacts, and also once the artifacts has been zipped or extracted, it could be uploaded into the cloud, and later on the continuous delivery or the continuous deployment stage, it could be deployed on the infrastructure. But that's a brief on how build step. Also, building could be used for building Docker images. If you have containers or Kubernetes either on-prem or on cloud, you can build your own image, and later on you could deploy these containers on your existing infrastructure, even on cloud, on AWS EKS or ECS, or even on Microsoft Azure ACS. You can deploy your containers on the cloud, or you can deploy them on-prem. So that's mainly the building process. You are building the container image on a Docker repository. Also, it could be a Docker Hub, or you can upload into any other container registry. Mainly on Azure, we have the Azure Container Registry, and on AWS we have the Elastic Container Registry. So that's the build process, and then the testing of the continuous integration. With every single commit, we could test the code that there is no errors, in the code. We could make linting testing to check errors and warnings. Mainly not only errors and warnings, we can check others, logical or logical errors on the code. For instance, extra spaces or extra tabs, or if condition or for loop, it will never be executed. We can make linting testing on this continuous integration testing stage. Also, we can do unit testing by testing our code. For example, variable that will be the output of the code, it can ranges from x to y. It could not be greater than y, so we will test that. If the result is greater than y, the pipeline will fail to be executed and the code will not be deployed on the infrastructure. That's mainly a brief of the continuous integration testing. So that's the stage of the continuous integration, which is building and testing. Mainly this continuous integration, maybe we could segment that into multiple stages, and each stage could have multiple jobs, and each job will be executing different tasks, and even these tasks could be executed either sequentially or parallel. Later on, even in the continuous deployment, we have stages, jobs, and steps or tasks. Also, it could be deployed in a sequential or in parallel form. But also, the cool thing in the continuous integration is that the continuous delivery or the continuous deployment, we could make strategy of deployment. The strategy could be in a linear format. For example, the canary deployment, we could deploy 10% of our production infrastructure with the new code and test it with a bunch of automated testing, such as performance testing, smoke testing, whatever the testing is being used. And once all of these testing executed successfully, we could deploy the other 90% of the production. We could deploy even 30 and 70. Also, we could deploy using the exponential curve of the production we deploying based on the time. And once we feel that there is an error or customers has been affected or impacted by these changes, we could pause or stop our pipeline. So we are deploying on our infrastructure. Our infrastructure, as we said, could be on-prem, it could be on cloud, it could be containers, either on-prem or on cloud. So whatever it could be serverless, for example, Lambda on AWS or Azure Functions. And these infrastructure are even provisioned mainly either using the GUI or the wizard of the Azure Cloud or the CLI or the SDK. But the cool thing is we can deploy this infrastructure using infrastructure as a code, and this code is stored in the repository. For example, we can have Terraform or ARM templates or CloudFormation on AWS, and once the repository is triggered with that, the code will be executed and the infrastructure will be provisioned. Also, I forgot to say something in the continuous integration or the continuous deployment. Mainly for the continuous integration, we could use multiple tools in continuous integration. In this demo, we are using Azure pipelines for the continuous integration and continuous development, but there is other bunch of tools. Mainly there are three types of continuous integration: either software as a service, like GitHub Actions. We could use GitHub Actions for building servers, or mainly it's not servers or machines, even it's not virtual machine, it is containers. Containers running on the cloud that mainly focusing on building other containers and taking a snapshot or an image from the container and deploy them on Docker repository, or it can be used, as we said, for testing. And once this continuous integration stage has been passed, the container that has been deployed for this purpose is totally destroyed. So that's for software as a service. You could also use Circle CI, I think it's called Circle CI, for software as a service and continuous integration. Also, if you are working on-prem, you could use Jenkins, one of the most continuous integration tools, which is Jenkins. Also, there is Jenkins on cloud, Jenkins on AWS, and Jenkins on Azure. And last but not least, you could use other continuous integration tools on cloud, which is cloud native. For instance, you could use Azure pipeline. That's what we will use in this demo. And also we could use on AWS the code pipeline, which is responsible also for code committing and code and continuous integration, and then continuous deployment or continuous delivery. Mainly the difference between continuous deployment and continuous delivery is that continuous delivery is more automated than the continuous deployment. The continuous deployment requires a human approval to make sure to deploy the infrastructure. Maybe it depends on the business policy. If there is, for example, maintenance window could be used for deploying on your infrastructure, so I have to use continuous deployment. But for continuous delivery, it's just building, testing, and deploying using our strategy in an automated way. Once it's deployed on the infrastructure, of course, our infrastructure needs to be configured if it's triggered by the infrastructure as a code in the repository. Once it's triggered, I could run automatically the configuration of this infrastructure. So of course, our infrastructure need to be configured. Either if it's working as a web server, we should install Apache or Nginx or Tomcat, and then exposing port 80 or 443. So these configuration even could be the tools for using this configuration could be Ansible, Chef, Puppet, SaltStack. There are a lot of tools. Even there are cloud native tools such as configuration state in Azure or OpsWorks and AWS. But all of these tools could be at the end are coding. So, and this code could be in the repository, and with every trigger it could be reconfigure the infrastructure. For example, if we have a set of virtual machines, scale sets, and so on, all of them will be configured using these configuration management tools with every change in this repository. Okay, once the code has been deployed on the configured infrastructure, our next step is operating and make some automated testing, as we said, performance testing, load testing, stress testing, and if these testing succeed, we are going to make some monitoring tools to monitor either on the infrastructure level for monitoring memory, CPU utilization, and on the operating system level. For instance, if there is processes taking a bunch of the CPU utilization, also we could monitor at the operating system level, and also at the application level we could monitor some aspects or behavior of the application. If there is unusual behavior, all of these monitoring tools could be used and sent an alarm to the developer, and the developer will detect the bugs and the actions of the application, and he will begin again to committing on the repository for the application, and committing on the repository for the configuration management tools, and last but not least, committing in the repository for the infrastructure as a code if there is a change that could be done in the infrastructure. That all is our introduction of how DevOps automation works. Mainly we will not focus on all of that. We will focus only on the CICD level, with committing into our repository. Our repository will be GitHub, and then building our container or our server, which will be Ubuntu in this demo. The Ubuntu is going to install the required Python libraries for building our application. Once it installs the requirements, it could be some linting or unit testing. We have example of linting testing will be make at the end of this demo. Once the building has been finished and the testing, we're going to deploy on our Azure infrastructure, which will be an app service inside an app service plan. And of course, our app service could be you either on the Windows operating system or Linux operating system, and we will say what is the programming language we will be used. Python, Ruby, Go, TypeScript, whatever. But even this even these steps will be automation, since we will use a tool in Microsoft Azure for provisioning the web app in an automated way, and this tool is smart and intelligent enough to know what is the proper operating system and what is the best programming language we could use, depends on the code inside of your repository. Okay, that's a brief of what we are going to do in this project. That should be the output of our CICD pipeline. So as we said, we have two stages, the build stage and the deploy stage. Here you are free to rename your stages, whatever. In here example, we make build stages for building our environment and testing using linting testing, and then we are deploying on Azure infrastructure. Here is the artifact has been downloaded. So let's go a brief what's going on. First of all, we initialize the projects. Check out here is as we said, once the pipeline is provisioned, automatically triggered has been occur. So with every trigger and with every starting of the execution of the pipeline, as we said, we say what is the branch that should be used to be triggered, and with every commit and with every build, this branch has been taken into another branch called whatever Microsoft Azure call it. So it takes a separate branch from your branch and copy the code, and then once the build process has been finished, this branch will be destroyed. So we are using Python 3.7, installing the requirements, which is the libraries we are going to use. Some libraries will be used for the application, such as the Flask, and other libraries will be used for testing, such as PyLint and PyTest. The next step is we are going to archive our files with by zipping the whole project, upload the project into Microsoft Azure, and then we are going to destroy our branch. That's a building step. Our deployment step will downloading our artifact, which is a zip file, use the Python version, which is 3.7, deploy on Microsoft Azure Web Service. Okay, so these are the steps in the repository. Feel free to read them, and these are logs that we will investigate, and that's our reference. Okay, so we have cloned our repo. Okay, so here's our repository. We have, first of all, the let's take a look of the makefile. Makefile is one of the best way of automating automation. With the concept of makefile, you have separate sections, and each section has a bunch of commands, and just simply by typing make and the name of the section, you should execute these commands. Okay, so what first of all we need to prepare our environment. Mainly this is give an execution privilege for the setenv script. This script is going to export your environment on your bash shell or z shell, whatever the type of the shell you are using. But unfortunately I will not be able to get this file, or I will not be able to env to see my environment variables because it has my credentials, but I make an example of that. You should put your Azure subscription, the location of Microsoft Azure, the service connection. Also, I have a link here on how to make the service connection, which is a must in order to make the Microsoft DevOps see your subscription on Microsoft Azure. The resource group, you can rename it whatever you want. The Flask web app, the pipeline name, the pipeline description, the organization name. You have to put your organization name here. So in Azure DevOps you have a hierarchy which has the organization and then the project, and then in the project you make your pipelines, builds, boards, etc. You put the project name here, and you put the name of the repo that will be triggered. Make sure to put either this repo or your repo if you fork that repo. And then the virtual machine, that's what I'm talking about. It's not a virtual machine, it acts as a virtual machine, but it's a Docker container at the end. What is your environment name? You can make bunch of environment, either production, development, staging, whatever the environment is, and the Python version that you are going to use. Okay, so what in our make file, in order to, first of all, we have to run preparing the environment after modifying the .env file. I think I do not have my .env file here. I need to re-upload it. And then the automate, or I think if your environment already set up, you will not need to re-upload your .env file. And then you will run make automate. What make automate will do, it will give the execution privilege to the script called run Azure, and it will run that script. Let's have a look on the script run Azure. Okay, what that script will do, first of all, is going to create an Azure resource group. That is the resource group that will have our Azure web app and of course our Azure service plan. And then we are going to create our service plan and our web app. This is one of the cool way in Microsoft Azure to fast deploy service plan and web app by AZ web app up and specify your resource group. Even you cannot specify a resource group, he will create it for you. And then -n, you give the name of your application, and what Azure will do is will upload your application in the current directory you are in, which is this directory. So he will upload the files of this directory into your Azure web app. The next step is going to make our variable group. The concept of the variable group, in order to make things automated and dynamically, you can configure different variables. So mainly what we are doing here, we are uploading our local variables into Microsoft Azure variable groups, which should appear here. Mainly no variable groups now because we have not executed the command. So simply we are making variable group with this name. Authorized true means that you're giving the permission for all of your pipeline to access this variable group. You specify your organization and project name, and you assign your Azure service connection, which is mandatory. And then the web app and these are the variables. I think there is yes, the option dash dash variables, and then you specify your variables as your connection ID, web app, VM image, and your environment name, as well as your Python version. Once you deploy your or you make your variable group, we are going to create your Azure pipeline. Mainly you could do that by making the pipeline and following the wizard, but we make things more automated. So we will make AZ pipeline, create the name of the pipeline, the description, organization, project, and here we are going to specify our repository. That's the repository that in every single commit done on the repository, it will rerun the pipeline from the building stage to the deployment stage. If you are using Microsoft repo, you could just put the name of the repository, but since we are using GitHub, we have to name the repository, put the branch and the repository type, which is GitHub, and last but not least, the most important file is the YAML path, which is Azure pipeline.yaml. That's the code, that's the pipeline as a code. If you are familiar with Jenkins, this is the Jenkins file. If you are familiar with AWS, this is the build spec file. So the Azure pipeline is the most important file. Let's have a look on it, which you are triggering the master branch. In every commit in the master branch, the pipeline will run. The variables are the variable groups that have been created. And since this is a one-time variable assignment, so I put it here, which is the working directory are working it in the Ubuntu image that will be created, which is a container behind the scene. And then the stages. As we said, we have 2 stages. I think we could see that in GitHub, it would be better, which is Azure pipelines. We have the build stage and the deploy stage, and in each stage we have jobs. We have a single job here and a single job for deployment, and every job we have the steps or the tasks, and here we are specify the Python version, and look, we are assigning our variables in our variable group, which is assigned in the Azure pipeline in this section. So we are using Python version, and that's the script that will run once the image has been provisioned or the container has been created. First of all, we are making a virtual Python environment. We are activating the environment, and then we're running the make install, which exists in the make file. If you see our make file, make install is going to pipe install and upgrade our the pipe tool. Pipe tool is mainly the package management tool for Python, and then pipe install dash r the requirement.txt, and the requirement text are Flask. Mainly I need to give an overview of what we were going to deploy. The Flask machine learning app, it's just an API call, a post API call to the application, and the application should with an input values, and the input values are written in a JSON format. We will see it later, and the application will respond with the prediction of the machine learning app. We will see that later on. The pandas does scikit-learn, and the pylint and pytest. These are the requirements that will be downloaded once the container has been launched. The display name will be install requirements, that what we have seen in the screenshot. And then we are going to archive our file in the zip format, and then we are going to upload our artifacts, and then the deployment stage. We are going to use the Ubuntu which is in the variable group, and the steps which will be we are going to use a Python version which is 3.7, and then we are going to deploy on the web app that should be deployed on the run Azure script, and then we are going to upload our package, and of course we have to put our service connection ID. Okay, that's mainly all the steps need to be done. If we go in that script again, we will not found, we are committing our linting testing for now. We are not going linting testing, we are just going to install the requirements and build the artifact, zip the artifact and upload it. Okay, let's go to the most interesting part. We make automation. But before that, I just need to give a brief of the make prediction app, which is calling our application using an API call. You can use Postman or any API call app, or you can use the curl command, and these are the inputs in the JSON format, and this is the content type, of course, JSON, and this is the endpoint of our app service, which is in the local environment variable, and our port will be 443 port, which is the default port Microsoft Azure is using for app services, which is a HTTPS port. Okay, so let's go. So simply you can automate and build everything at once, but I need to make things step by step. So what make automate do? It will run the script of run Azure. We can simply run each command separately. What we are doing here, we are creating our resource group on Microsoft Azure. We see our resource group. Our resource group should be created here. As you see, it's succeeded created. Production resources. I think it's still creating. Oh. Okay, let's refresh the whole page. Okay, here is our resource group, production resources, and what we are going to do right now, the next step is, as you see, we are going to create the service plan and the web app service using the awesome command, which is the az web app. Also, if your web app already exists and you need to update it, you could also use this command to update your web app. And as you see, the web app does not exist, so he take the decision to create our app service plan, and then is going to create our web app. The cool thing also in the app service plan, as we said, is intelligent enough to determine the operating system, which is by the way, the default is Linux. Yes, Microsoft, the default is Linux, but also it determines the programming language based on our code, which is Python. Also, one cool thing in that command is using the free tier web app service plan. I think it is the F1 service plan. So you can run this command simply for deploying your app service plan and web app. So if we refresh that, we should see our resources. Yes, here it is. We can take the endpoint and try to open it. Mainly that's our web service, but we are going to run the 443 predict but of course we will not be able to see it from the GUI. We have to use either postman or the curl command. I think the deployment is still deploying. Maybe you can use another shell. So we can run simply this command. Let me predict is using port 443. Still the URL not found since the application is still deploying. Also we could see the log stream from here. And all of these, in any request, it will be in the log. Also, an awesome thing here is that the app service plan is also behind the scene at the container. Everything is a container nowadays. Is that the app service plan are building a container behind the scene with a random port 7892 and map that to port 8000, but that's on the what they call the overlay network layer. But on the cloud level or on the underlay network, we are going to map this port 8000 to port 443, which is the HTTPS port. So let's try to request that. Still not working. But as you see, our request, here is our request in the log. And now the container initiated successfully. Here it is. And if we take, he's still making health checks, but if we run the command now, we should be able, yes, to see our predictions. Here's our predictions, and we will see the log has been thrown there. Okay, now our web app has been deployed successfully. Our next step, yes, here it is. Our next step is creating our variable group, which simply behind the scene will be uploading our local variables group to Microsoft Azure DevOps. We should see our variable group here. Yes, here it is. Unfortunately, I will not be able to open it since it has my service connection ID, which is my credential. Okay, and the most cool step is creating our Azure pipeline. So once we deploy our pipeline, it will be triggered. So the building step will occur and the deploy step will be executed. We should see that in our pipelines. And here a question which asks me, do we are going to make a new GitHub service connection? Of course, you have to integrate your GitHub account with your Azure pipelines, and also we have a tutorial here on Microsoft saying how to do that, which is integrating the GitHub with Microsoft Azure. So since I make that integration before, I'm going to choose my GitHub account. And as you see, the pipeline is deployed successfully. If we let's refresh that, here's our pipeline. Yes, and once the pipeline has been deployed, it will be triggered, so the pipeline will run automatically. As we see, we have two stages, the build stage and the deploy stage. For the build stage, we are going to initialize the jobs. As we see, we are going to check out a separate branch, use Python 3.7 and install the requirements. As you see, the pipe install dash upgrade and the pipe install requirements is installing, is downloading all of the libraries and prerequisite libraries needed for that build. once it is built successfully, we should be able to see the files archiving in a zip format, and once the zip format finished is archiving all of the files. Here it is, the .get, the make file, all of the files in the repo are archiving and uploaded on Microsoft Azure as an artifact. Now he is in the uploading stage of uploading the artifact on Microsoft Azure, which later on will be downloaded to the web app service to be deployed on it. It's destroying our destroying the branch that has been created, cleaning up. Once this job has been finished, the deployment web app is going to be begin. And here's the main thing in the CICD pipeline, or the pipeline as a code, is that the stages are running sequentially, but the jobs are running sequentially by default, but you can append them using strategies. You can use strategies by running sequential jobs or parallel jobs, or even in the deployment stage you could use other strategies, either canary or exponential deployment or blue-green deployment, whatever it is. Okay, here is downloading the artifact. Has been successfully downloaded using Python version 3.7, and then deploying that into our Azure web app. If we see the logs of the Azure, still no action has been taken, but once the deployment occurs, the new logs should be executing, and then he will destroy the existing container and create new container with the new code. We'll see what will occur. I think he is unzipping the artifact to be able to deploy the code. And of course, if we try to make predict right now, it's still working, maybe still not deployed. Here is our prediction. We make two predictions. So the cool thing, once the deployment occurs, with every change in this repository, these steps should be deployed again. With every single change, as we see, the deployment successfully deployed. Let's see the logs as he redeployed the container. As we predict that the container will be destroyed and new container will be exist. Yes, it is. I think now the deployment finished. And if you want the prediction, okay, now we have the new deployment. Yes, and the prediction is running as well. Okay, so that's the cool thing. In every commit in the repository, even in the readme file. So let's echo, for example, new line in the readme file. So if we see our pipeline, as you see, this is our pipeline, and we have just a single build, and a single deploy. So if we make a change even in the readme file and try to refresh that, we will see another deployment should occur. Since that is a commit in the repository. Okay, so first of all, we commit on the local repo. We have to make an add. Mainly this is a alias. Get add should be like that. which is adding everything, and there is get commit -m, maybe it should be triggering the repo, and then get push. We have also alias for get push, which get push, which alias to push on the master branch. Push. I think we need to. Okay, what I do is I re-authenticate my get repo. We will make get push again, and he is pushing to our repo. If we go to our pipeline, yes, we should see a new build occurs due to this triggering, with a new build stage, a new deployment, and that's the continuous integration and continuous deployment with every single change the developer make in his repository is passing through a whole pipeline of continuous building. Continuous testing would not make continuous testing, by the way, we could make that, and then continuous deployment on our existing infrastructure, and it goes into the production without human interaction of make testing the coding, or everything is automated with no errors. Also, we could make continuous testing by adding lint testing. So for instance, if I modify that, let's see that from GitHub, it will be better. In Azure pipeline, we could uncomment that, which is make lint, which is check either for errors and warnings and whatever the code you can exclude. So I will make file, just PyLink, and disable whatever the codes you need to disable, and that will give you a rating of your code. And of course your rating should be 10 out of 10, and even in this automated pipeline you could set a range of or you can put a threshold or a floor for your rating, and if your rating is less than that, the build will not execute it successful. So just you can uncomment that line, and now you have continuous testing as well. Okay, that's all. As you see, we are redeploying our code, and it will be redeployed on the production environment. That's all for CICD pipeline automation, and thank you.